Hello, my name is Yuichi Kikuchi from Panasonic, and my presentation is titled Organizing Security Issues Discovered During Product Testing for Easier Consumption by Product Developers. Here is today's agenda. Please allow me to introduce myself and what I do at Panasonic. After graduating, I entered the security industry 6 years ago. For anybody that has performed security testing, however, has the experience of an angry developer yelling at you as a developer not understanding what you are trying to communicate? I have had many such experiences in my time at Panasonic. Each time this occurred, I always went back and thought to myself, there must be better ways to perform tests or communicating information. My talk will focus on what we have tried at Panasonic on how to better communicate with developers as a security testing team. This is my first time presenting at an event like this, so please go easy on me. Panasonic is a company that specializes in home electronics, while we also provide many B2B products and solutions. The Product Security Center at Panasonic has been active for almost 20 years and has provided services group-wide and collaborations with external entities. I will start with some of the issues I have encountered in the past when communicating with product developers. Security testing as a PSC mainly targets Panasonic products prior to shipment. The aim is to identify and address as many issues as possible to prevent security incidents. Product tested include IoT devices such as home electronics, automotive devices, industrial devices, and may include wireless and or Bluetooth interfaces. Others are web applications, Windows desktop applications, smartphone applications, etc. Our security testing not only looks to identify vulnerabilities, but also look for quality issues to ensure security throughout the entire product lifecycle. Our team has started to assist development teams to perform some security testing at earlier phases of the development cycle, since testing done by the PSC tends to come right before shipment. We promote product security as part of quality assurance group-wide. Our team performs tests on over 200 products and discovered over 2,000 security issues annually. We would like our developers to concentrate on product development. However, with rapid technology advancements and complex security issues arising, it has become difficult to create reports that make it easy for developers to make informed security decisions in a reasonable amount of time. In order to provide better services to our product developers, I took some time to review our current test reports to see what can be done to improve our reports for easier consumption. As an internal testing team within Panasonic, it is easier to establish communication channels with product developers and the security champions at the development site. By working closely with them, my hope is that we can improve the security of all Panasonic products together. The rest of my talk today will focus on my attempt to help improve the quality of information provided to our product developers. My first thought was using commonly used labels associated with security information. Only providing technical information on the vulnerability has caused confusion in the past. So what can we provide? In addition to vulnerabilities, we also look for weaknesses and quality issues. So commonly used labels and scores for vulnerabilities cannot be used. It is not as easy as just including every piece of information that we can. If the developers are not able to understand what they are looking at adding more information just adds more confusion. We have the original metrics and labels. However, using these cause issues when developers have to communicate externally. So how can we organize all this information gathered during security testing? To start this organizing process, I broke down my role. What information each role is looking for from the testing reports. The role are developers who do the actual coding. For the products managers who serve as the communicator between the developers and upper management. And lastly, we have the business managers who also have to consider safety and trust on top of security. And each role is looking for different information to perform their role. For example, developers want information on what the security issues are, how they can be fixed along with the assessment policy, or how the test items were selected for the given testing engagement. Managers are looking for information on how to fix the discovered issues along with the assessment policy, including what tests did and did not uncover security issues. Lastly, the business managers want to know whether the security issues has been addressed and any remaining risks. The level of abstraction of this information rises as you talk with people higher up in the organization. This slide is a side-by-side comparison of what we currently include in our report with what I just mentioned as necessary information. First is the root cause of the discovered issues. We do provide root causes for the issues discovered based on what has been observed. But there are cases where we lack details in the reports. For example, when communicating replay attacks, we have sometimes failed to mention whether there is no mitigation against that attack itself, whether the communication channel is not encrypted or any other cause is the actual issue. Next is a fix for the security issues. Currently, we just provide a list of potential methods to address the issue at a high level of abstraction. This has also been a problem, especially when root causes are not properly identified. This list could include fixes along with workarounds without properly labeling them. Due to not properly classifying the security issues, we were making it difficult for the developers to identify what fix actually mitigates the discovered issues in their products. Next is the security assessment policy, or process on how the test items are selected. This has not been provided. We have provided what was tested for each engagement, but have not included why each item was included. Security assessment results with evidence and logs. This has been provided and will continue to do so. It is not on the slide, but would like to quickly make a comment of issue scoring. We have an original scoring system that it used and have started using CVSS version 3 for some issues. Today, I will focus on the item in red. The policy and scoring can be solved after the first two are resolved. In order to improve the information to be provided, I revisit the roots of our testing service on what we provide to our developers. First up is providing root causes. In addition to information on the vulnerability, I came to the conclusion that including the weaknesses that led to this vulnerability can solve most of the issues that I have seen. Our testing and reporting is closely aligned with the test items we have. Due to this, a single report could contain multiple vulnerabilities or issues, which made it hard for developers to understand. In order to place a focus on weaknesses when pointing out security issues. I realized that it was necessary to reorganize and reclassify the test items we have. When doing so, I hypothesized that doing this on a weakness basis would be the best way to go. The next hypothesis is if we are able to properly identify the root cause, we should be able to provide more appropriate information on fixes. One thing that needs to improve is the organization of this information, most notably properly labeling potential fixes, workarounds, and other information as appropriate. Also, if we include CWE IDs in our reports, it will enable developers to easily search for more information as necessary to better understand the issue. The hope is that by organizing the information we provide in this way will help our developers to better understand the issue at hand and make more informed decisions on how to secure their products. I took a deep dive into CWE 1000 research concept to help achieve my goals. Now, I will get into how I use CWEs. CWE 1000 research concept is a view that contains all CWEs. The thing that drew me to this view was the 10 pillars that it starts with and with its tree structure. I felt that it would allow me to organize the information that I was looking for. In this view, not only are the weaknesses easier to find, related weaknesses can easily be identified. I went through all of the test items that we have and discovered that all items fit within each pillar. At the same time, due to the black box nature of the testing, I noticed the difficulty in being able to cover all pillars evenly. This time also helped me to identify test items that we could potentially be missing. When I started my attempt to organize and classify security issues, I was thinking of ways to do this by product functionality, such as authentication, encryption, or types of attacks such as DDoS, but at the end, using these pairs to assign CWs to the issues discovered was most efficient. This is the outline of why I did associated our test items to the CWEs. First, I took all our test items and assigned CWEs. When doing so, I tried to go as deep as possible to catch the weakness in more detail. For test items that had more than one CWE assigned, I broke down the item so that it became one CWE per test item. Test items with more than one CWE could potentially contain both a root cause and what had occurred in the report, so this was necessary. For example, a test item called verify configuration could mean a tester is looking for multiple things, so these were broken down by what had occurred. When doing this, I also took some time to see if the test we are performing cover what is contained is not just CWD, but our internal guidebooks. The last step was to reorganize our test items. Each test item assigned a single CWE ID and the wording of the items was unified. Here is a list of the test items we have for the SSH protocol. There are items that call for fuzzing check configuration, encryption, etc., and others that rely on technical know-how of the tester. And to the side, I listed the weaknesses associated with the SSH protocol vulnerabilities. Please note, this is not a complete list. In this example, SSH has functionality to both encrypt the communication channel and provide authentication, so as a protocol, many potential weaknesses are listed. As an aside, when I first started this, I did not expect to go through the entire CWE databases. It was tiring and I made many mistakes along the way. But I do believe the creation of this list will be valuable for us in the future. There did come a point where I had to just decide on the CWE. At the end, my breaking point was whether the weaknesses was testable or not. In the past, our reports just contained misconfiguration or something similar to that. The developers probably had a hard time identifying what was causing the actual issue. This was where I noticed that our reports contained a confusion mix of what the test uncovered the vulnerability and its root cause and how to fix the issue. Before getting into the reporting, here is a classification of weaknesses using CWE 1000 for the SSH protocol. CWE IDs surrounded in red are listed in the chart to the left. What I ended up creating was a list of the weaknesses or what you need to check for. Let's take CWE 749 and to check for that. From this test item, I'll repeat this for each identified weakness. The other CWE IDs in the tree are there to show the structure as well as being for the reference. This tree structure allows me to create a better visual for our testers to see what weaknesses or root causes we are testing for. And by identifying the CWE IDs for each protocol, here is the SSH. It allows the tester to see what test items exist and makes it easier to identify which test items are selected for a particular testing engagement. Having this information organized in this way can be valuable to our developers too. All weaknesses under CWE 1390 are related to authentication. Not only can we point out issues in the current product, but by providing this information, I hope that it enables our developers to better design products by seeing potential weaknesses in this way. SSH has many functions, which leads to many test items and associated CWEs. Let's look at TCP. As I expected, TCP does not have as many as SSH. Looking at the actual data require application testing. So for product testing, I looked at the function used until the handshake process. That was how I associated our test items with CWEs. The next few slides are about how we will provide this information to our product developers. On the left is an image of the reports that we currently provide. More details such as version numbers are also included. An improved version of our reports, which is shown on the right, will include CWE IDs along with a better breakdown of how the issue can be addressed. This is broken down by an actual fix, workarounds, and other things that can be done to improve the overall security around that issue. Here is a more detailed example. The issue is the existence of API that includes password without session information. In the past, we only had expected threads, but this did not communicate to the developer whether it was an access restriction issue or whether the function itself was necessary. The root cause of the issue was not listed or was hard to identify, which led to developers scrambling to figure out how to fix or even in some cases not fixing what was necessary. In some cases, we would include other issues to make it seem like a more severe issue to encourage a quicker fix. For fixes, we will separate actual fixes from workarounds. Actual fixes will be required, but other information can be optional. Along with the testing reports, I believe it would be helpful to our developers to provide a mapping of the weaknesses that were looked for in the testing engagement along with the test items to better identify how to fix issues. Scoring can be used for prioritization, but I believe starting here will allow our developers to better identify business risks for a given issue. And the hope of creating and providing this information to developers teams is that it will enable them to better incorporate security at earlier phases of product development, which could lead to discovery of fewer issues during testing. This is a full set of information what we can provide now. On the left is the detailed security test report, where the security issues are associated with the weakness, IDs, and other information. The vulnerability information is important, but the root cause is the information that enables the developers to better determine how to address a given issue. The second piece of information is the mapping chart of the discovered issues. This provides a visual of the issues discovered during the testing. I was able to take a few steps in the right direction. There still remains some additional work. First is to educate our developers on these classification schemes and CWE. It may take some time. At the very least, it would be extremely helpful if they understand the concept of each CWE 1000 pillar. They do not have to memorize every single CWE, but understanding that there is a tree structure should help their understanding. Due to the black box nature of some of our testing, I had to use CWE20 and other high abstraction IDs. Through discussion with our developers on the actual fixes, I hope to be able to assign more detailed CWEs in the future for these. Test item selection and scoring is a difficult thing, which I have not considered in detail yet. It's something I plan for in the future. Some initial future work includes applying this method to our old report. When I started this project, I went through the 20,000 reports we have and tried classifying them by vulnerabilities. And other thing I could think of. I was not able to uncover any trends at that time, which led me down the CWE path. If there is time, I would like to go back through and assign CWEs to C. If there are any trends in the weaknesses that our developers include in product. The other thing I want to work on is automating report creation. With this breakdown of information, I think there is a way to automatically generate, or if not most of the reports. Some still may require a bit of handcrafting, but automation will allow us to save time and improve the overall quality of the reports. Today, I share the method I use to generate higher quality test reports to our product developers. Instead of focusing on vulnerabilities, the approach I took was to focus on weaknesses or CWEs. And to enable our developers to focus on fixing issues and not trying to decode vulnerability reports. I tried an approach to better break down the root causes of vulnerability into their weaknesses. Creating and including a visual chart of the weaknesses should also be helpful. Through this process, I was able to enjoy how to communicate the issue on top of the discovery part. This also allowed me to find a way to efficiently generate our test reports. And my end conclusion is that I discovered that security testing and CWD were a good match. There is more work for me to do, but I do hope that this was helpful for you. Thank you very much.
Thank you. Okay, now the time for Q&A. Yeah. Please come to the standing mic for questions. Please.
Hi, thank you for the presentation. I have tried, I use CWE also. I am surprised and impressed that you used CWE 1000. If you expand it, there are how many, 300 different CVEs, sorry, geez, CWEs, acronyms, in that graph, in that hierarchy. So you addressed this in the presentation, but how difficult was it did you have to read every single one of those and decide to use it, to include it, to give it to the developers or not? Could you discuss that a little bit more? Yeah.
Yes.
Yeah.
Okay.
Yes. Oh, I read to all CWDs about 1,000 CWDs. Thank you. Question.
Okay. That's impressive. Any other question? Actually, I have two. So wasn't it too much burden for your assessment team? I mean, yeah, it's nice to provide a structured and more information for the developers, but I thought that it's going to be a lot of burden for you or your team. So how about that?
Slow one. That is finished.
Finished.
Yeah.
Okay. So, but you need to create a report in a different than our older ones. Is there any additional work that you need to do?
Yes. Additional. Yes.
Okay.
Still working.
Still working on it. Okay. See. Oh, here's another.
So following on that, with what you mapped so far, does that make it a repeatable process for your assessment team? So going forward at the next assessment, are they using these same test cases that are already mapped as CWEs?
Yes. So that is used CWDs. So repeat this. Thank you. Question.
Any other question? I think it's a little bit early, but please give another round of applause. Thank you.